Good evening, all. Today we have third session on advanced natural language programming, FDP. So, third day we have guest speaker Dr. M. Anand Kumar sir is with us. Sir will continue rest of the given contents in the brochure. Now I invite Dr. M. Anand Kumar sir to deliver the lecture.
Yeah, Kishore, I'll share my screen once again.
Okay, you can share. PPT is visible, sir.
Audio not audible, no sound.
Muted. Yeah, am I audible now?
Yes.
Yes, sir. Yes, sir. Audible, sir.
I'm audible, right?
Yes, sir. Audible, sir.
Fine, I'll continue. Yeah. So fine. So the first day we talked about natural language processing, and then the second day we have seen the applications of natural language processing, the basic level applications we have seen yesterday. And now I'm going to continue the applications. Now the application in NLP applications, I'm covering some of the applications with respect to the LSTM models, the LSTM applications also I'm going to cover today. And at last, I thought of giving some demo of today's actually to the one NLP application or one or two NLP application I'll take the hands-on code. I'll just show the code and then I'll just explain that. I cannot explain the line by line. I just to say that how to come up with that models and what will happen each models and how to tune the features and other things. And next day, I mean the tomorrow, what's my plan is tomorrow we'll start with the word embedding. Tomorrow we'll start with word embedding and other embeddings, completely embeddings. And today, if time permits, we'll initiate the embedding also because embedding again, it's a big chapter. So if we have time, and then I'll start embedding today itself. And last day, we'll talk about large language models. Fine. And tomorrow we have some demo to the word embedding also. Fine. So when you come to the applications, NLP applications, we have seen this author profiling application, I guess. Yeah. And I said about the native language identification. I have given an example of the model what we created for 6 languages, 6 Indian languages. It means that the model will not be in the text will not be in any of the 6 languages. The text will be in English only. The English text will be given to you. The job is to find out who wrote the English text, whether the person is from Malayalam region or the person is from Hindi speaking region, who wrote this English text. That's what the contest. That's our data set is available. As I said that the accuracy for this model is the state of art is around 48 only. There are a lot of provision to improve the accuracy. So if you are interested in working further, you please contact me. I'm happy to share the data. Fine. So now why I analyze? So I said these things also I explained, I guess. So I'll just move to the next application. Fine. The next application of the social media is the very well-known application, sentiment classification. So there are a lot of variants in sentiment classification. So starting from I can say starting from the 2 level, saying positive or negative, saying positive or negative, or highly positive, highly negative, and including neutral. So like that, there are many levels in natural language, sentiment classification. So here I have taken a small example of movie reviews. Say for example, the starting of the, this is the review given by some user. So see that I'll just read quickly. This film was just brilliant casting, location, scenery, story direction. Everyone's really suited the part they played and you could just imagine being there, something. So from here you can easily understand that the review is positive because of the phrases like brilliant casting, so the location, scenery, the everyone really suited the part, so and amazing actor. So these kind of positive words will make will make this model to understand that the given text is positive. So there are a lot of what happened in English and very few things for Indian languages. So taking Indian language text and then working on the sentiment and then other things. So that kind of work also started nowadays. And there are some data sets available. Even we worked some data set and then we are released some data set as a part of it. What I can suggest you here is the extension is, I said no last time, yesterday I said something stands. This sentiment is a kind of well-known area now because so many research papers are there for sentiment. But what I strongly suggest you is you can think about something stands. Where suppose I'm writing this as a movie review and then I'm telling the movie name here. So I'm going to say that with respect to this particular movie or with respect to this particular target, I'm going to call this as a target. So this comment is or the statement, whatever given is positive. So where there are a lot of applications, if you go for a stance detection rather than sentiment analysis, as I said that one important thing is the government policies. So government want to know about GST. So say for example, government want to know about particular topic, say that's a GST. So you are going to refer only the reviews with respect to GST. So some people may say positive about the government, but we don't want that. So we want only the people who are talking about GST. How many are talking about positive about GST? How many are talking negative about GST? And I can say that how many are talking about improvements in the GST. And if you want to understand more, you can, as I said, that you can go in deep analysis and then say that, okay, this particular region people are not not adapted to the GST. So I have to modify my GST or the policy to accommodate everyone, because India is a country like, so it's very difficult to come up with a one rule or something, right? So one protocol or something, but definitely it needs a lot of scrutiny. So we have to cover each and nook and every corner of India to get their acceptance or to get their opinion and other things. Where for those kind of applications, stance classification or stance detection is the interesting research. So there are something called a training example. The famous data set is called IMDb data set. So it's available for 50,000. I think today also I have taken this data set for my demo. I'm taking this data set. I'm going to show the sentiment process. Yeah, this is what the example of the sentiment. I'm not talking much about the sentiment now. So you can see here that the negativity is there, neutral and positive. And neutral, if you say that, good job, but I will expect a lot more in the future. So that is neutral. So sometimes the people will confuse the neutral. General sentence also they'll consider it as a neutral. That's not a neutral. An actual neutral is it should be balanced with negative and positive. Fine. Now we are going to say the next one, next interesting thing with respect to yeah. So far we talked about the applications, the general applications of social media applications. Now we are going to say something like a deep learning based application. I can say the deep learning based applications for natural language processing. So when it comes to the deep learning based application, the first one is language modeling. The language modeling is not a new domain or new area. Language modeling have its world back 1960s. I can say that 1960s model, language modeling. The currently what we are talking about, large language model. So the base of the large language model is this particular language model. So from the language model only, we are talking this large language model. What is language model? So in everyday life, we are using language model. So say for example in Gmail. So in Gmail, if you are typing something, if you are typing dear, so the model will suggest dear Kumar. If you are typing something sorry, the model will suggest some sentence. The next word prediction. That is the best example for language model. Even your mobile phone has the next word prediction. If you are writing good, your mobile phone will suggest, are you going to say morning? Or are you going to say evening? Something like that. So that's called language model. The purpose of the language model, the earlier purpose of the language model is to predict the last word, preferably the last word in the sentence. If I write something and if I write something here, so the model will predict what will be the suitable word or what will be the last word, appropriate last word for this particular sentence. That is called word prediction, or that is the process to identify the word is called language model. The old models are purely based on statistical statistical language processing techniques. So it will find out based on the probability. So this may be the suitable word, this may be the suitable word. Finally, it will suggest you the best suitable word based on the probability. The earlier model, I'm saying the statistical language modeling. So nowadays, the new language model is, you can say that it's not a count based, it's a predict based language modeling where machine learning is involved in it. So machine learning is going to find out the suitable word. Machine learning is going to build a classifier and then it's going to say that this word is suitable according to this particular context. So that is language model. What we can do from the language model? So there are two things in the language model. So one is the language modeling will help will help you to understand or identify the fluency of the language. Or I can say that if you are writing something, the model will say that how the grammatically whether the sentence is correct or not. You remember that why I'm pressing this again and again is this is a base for large language model. So large language model also. So the large language model is good. Whatever the chat GPT, whatever the generative model, what we are seeing, all are good in generating meaningful English sentence, generating fluent English sentence. Now I'm saying English. So that the thought process, the prompt, whatever, now they are saying that if you are not getting proper output, the open AI is blaming the user. So they are telling that our system is, our GPT models are perfect, our open GPT, our AI, GPT models are perfect. They are saying that your prompt is not good. You define your prompt in proper way to get the results. So it means that, so they are, what they are claiming is that what I understand from the LLM or the GPT models are, they are very good in generating sentence. The remaining information, the how they are gathering the remaining, the content information in the output, how it's giving the content information. That is based on how you are giving your input or how your prompt is. So that's what the language models or large language models look like. It's generating everything. Fine. So anyway, we'll talk more in a large language model. As I said, that the first one is fluency. So it will identify, it will say that whether the first initial purpose of the language model is, if I give the sentence, it will say that how probable the sentence is. It will identify the syntax, whether the syntax is correct or not. But you slowly, the researchers modified that model to make the model to build, to generate word, to generate a word, last word. Now, the same model is generating the complete sentence. So language model, for the first one is to identify that, to find the fluency of the sentence, and the second purpose is to predict the word. I'm saying that now the improved language model is to the predict or generate the word, now the recent version of the language model, large language model, means is predicting the complete sentence, not only the sentence. Paragraph you want, it'll give a paragraph. You want a coding, you want some source code, it'll give the source code. You want to write some research paper, it'll give the research paper also. Fine. How this is happening? The question. So this is purely based on the data, whatever we have given. Say for example, if you say that, so how much data you are giving for the model to train, and how many iterations you are taking the model to learn the data and to understand it. Say for example, I'm asking the model to tell the story with a few iterations. So the model will say that something, it will say that heal. So the word is not at all meaningful. So then after some training, if I train with more data, then the model will tell something like this. Again, this is not meaningful. If I train with the more data, again, the model will come up with output like hello. Then finally, if I train with a huge, vast amount of data, the model will come up with the grammatically correct word. Again, I'm repeating, the first task is to generate the word. As I said that to generate the word, so model is generating the word. That's an example. As I said, the new models are good in generating the sentences. You see the other side example. If I train for few iterations or only with 50,000 sentences, the model will give output like this. So I won't understand anything from this text, right? So I'm adding some more data and I'm training more. Again, still, I first sentence, after seeing the first sentence, I had a doubt whether it's English or not, because the output is like that. Second, after the second one, it's look like English, but still I am not sure, because why I'm telling that's look like English, there are some words like a in, on, with a spelling mistake there, and I can say I and here, so like that. Some of the English words I can identify that. That's the reason I'm saying that maybe English. If I train more, so this I am saying that it may be 1 lakh data, this may be 10 lakh data, so this may be again 100 lakh data. So after 100 lakh data, if you see that, I'm getting so many words, how, and, is, so, and of, after some mistake is there, that, me, but it's not a meaningful. So it means that the model understood the language, model generate the text, but model failed to generate the sentence. Here the model generate the word, that's it. Model failed to generate the text. Now 100L, I'm going to increase that into 10,000 L, something like 10,000 L, 100 billion or something. So if you see that, if I increase it more, I'm getting some meaningful sentence. Why do want, so still some improvement is needed, but it's look like something meaningful. Wishing to himself, some partially the sentences are correct. So this is what happening in the large language model also. The earlier accuracy of the large language model was like this. Now it's improved further. It's improved in the generation process. So
Sir,
this
can I
is
ask
how.
a question?
Yeah, please, sir. Sir, I'm not hearing you properly, sir. Can you speak a little louder?
Yeah, my question is, you see, the
1 second, whether I'll check
is-
whether from my side I'll increase
Hear
the
me?
sound. 1 second. 1 second.
Can you hear me?
Yeah, I can hear you now, sir. Fine.
Yeah, thank you. So now the question is, you see, the even in this process which I have explained just now, there is
Yes.
the so-called learning process is based on probability of the next word only, right?
Yes, correct, sir.
So because more and more occurrences or instances of combinations of words have been observed or have been recognized by the model, it is predicting the based on the probability of the previous data which was trained upon it, the next word.
Yes.
Now it is
Yes, correct.
predicting.
Yes.
And also maybe more than one word phrase. But then you see, this is it is no doubt it's an interesting capability, but then you see it has got a inherent weakness in the sense it is not always possible for a user to train in such huge corpus. Like
Yes,
even in the
correct.
case of neural machine translation (NMT),
Yeah.
we found that problem with our own hands-on when we did it. A
Yes.
workshop we did about 1 year, 2 years back. Then
Okay.
we found that for whatever corpus we are able to provide, the performance quality is very poor
Yeah.
because it expects much bigger corpus of training.
Yes, correct.
So it is a very serious limitation, and we should think of other approaches, especially for Indian languages, which are highly structured and which are having very strict rules of word generation, like in Sanskrit grammar, Paunini's grammar, and all. We
Yes.
should develop our own Indian language model. It's not this is not the way to go about, because first of all they have aimed everything towards English and European language, not Indian language.
Yes, correct.
And secondly, in our case, it is not only it is phonetic, but it is a word, like a free word order is there, and so many other Karaka theory and Paninian processes of generative grammar. All those things are there.
Yes.
We should develop our own model. Do you agree with this, sir?
Yeah, I completely agree with you, sir. We should develop our own model. But here, so that's what. So you can see that I have mentioned that this is the output I have taken from the Stanford University slides of 2017. So the earlier model, the performance, now we are seeing the model performance. There is no doubt in that we cannot train a large language model right now with the infrastructure what we have in your institute or my institute, right? So
Correct.
I guess you there is something called high performance consortium. So where the CDAC Pune is heading that. So they have
See, that
yeah.
I would say that approach is just trying to repeat the same thing what they have done, but it's not a new design approach, new fundamentally not a different, using the same LLM but train large corpus of Indian corpus and all that. That is, there's no innovation there. If we
Yes.
can build a different model which is
Yeah.
more appropriate and it is leveraging and harnessing the features of our Indian languages, that will be an innovation.
Yeah. So here I just want to say one point here. As you know that, so English is as we discussed yesterday also, the English is very good in structure. So that's the reason without any information, their sentence information, their sentence consists of the syntax, all the information. That's the reason it's generating. As you rightly said that our languages are more influenced towards the morphology. We should have the morphology rich corpus or linguistic enriched corpus. So where we should not simply go behind the syntax to giving the sentence right sentences to make the model to generate the sentence. We have to see that how efficiently we can feed a morphology information also and other linguistic information.
As you said the other day, some knowledge input also should be there in addition to
Correct.
probability and training.
Yes. The
So that
knowledge base.
can be the inflections or the structure of the words and phrases and sentence, because
Yes.
all Indian languages are following similar pattern as same as Sanskrit.
Yes, correct.
We are
So-
working on this project, sir. We would like to collaborate with you. That's the
Yeah,
reason I'm
sure.
asking this course.
Yeah, definitely, sir. We will talk. Actually, we will definitely will collaborate. No issues. Happy to collaborate with you.
Thank you. Thank you.
Yeah. So as sir rightly said that the system, whatever it's having is actually it will work for English. The reason is again I'm repeating. So that is my understanding. The structure, English focus on the structure. So sir's point is I'm explaining this and then one direction and then I'm not telling anything about the Indian language. So if I say the Indian language, so this corpus, the collecting the sentences of 100 lakh or 1 lakh may not enough. So as we discussed that we need something a knowledge base or we need some morphology information to understand the complete text as well as to generate the text, because it's have two things, understanding the text as well as generating the text. Fine. With this, I'll just move to the next one. Yeah. So the as I said yesterday that the other applications I'm explaining with respect to other domains. So here I have taken that image processing with respect to image processing, where we can club the NLP, because now if you say that I am the NLP expert, I'll work only on the text, definitely that won't help. So we have to see the right things from the other domain and we have to take it and we have to use it. Say for example, the pre-trained model, there is a popular one called ImageNet, right? So the popular model called ImageNet. So ImageNet was first it was in a for image. Slowly people understand the power of ImageNet. So based on that ImageNet only, we come up with something called word embedding, and then now it's raised to the transformer, and then the LLM is also one type of pre-trained model. So when you say that uh, the knowledge or the good practices in the other domain should be absorbed in the other domain. I'm not only saying that from the image to NLP, there are a lot of things from the NLP, it's taken to the image side also. So there are, it's not from only the image side, there are other domains, speech processing domain or protein analysis or any other related domains. Because as the machine learning or deep learning comes into picture, deep learning or machine learning is a common, right? So any domain expertise can use machine learning to get some output. So not necessarily you can say that ML will work only on this particular type of data. Whatever data is that you are going to convert that into meaningful numbers or a kind of matrices, and then you're going to give to the machine learning model. So this ML or DL model indirectly connects the other domains. So such that one application I'm bringing here, this is also a popular application. Some of you maybe know that the image plus text. It's called image captioning. So say for example, the image is given like this here. So we have to build a model to say that the model should not say that the output should not be like a cat is there or not. That's a base level model. The model is intelligently saying that a cat sitting on a suitcase on the floor. This is the actual output of the model. I'm talking about 2000, this work also 2018 work. The person who is behind the X now, the X is now with Elon Musk, right? So if you see that the recent Elon Musk meeting, the top researcher that in his group is someone called Karpathy. He's the first person. He completed his PhD from Stanford, and he was the first person come up with a concept called image captioning. Karpathy. So if you are interested to know about the image captioning other thing, you just check his profile. He was the first person. Now a lot of research happening in this area. So as I said that, I'll take one more example. The dog is running in the grass. So you see that the image is given. I'm not telling that your dog is running or something. Dog is running in the grass with a frisbee. All the objects are connected and then they're given as a sentence. You see, it's counting. The model is counting. Two giraffes standing in the grassy field. Two people walking on the beach with a stuffed boards. So the model intelligently counting that. Yes, not only one guy or one person, two person, a cat, a tennis player in action on the court. The model may be confused whether he's, so it may be saying that there are some cases that the model get confused. So I'll show that. Some negative examples are the failure cases. Any ML system, we cannot expect 100% result, right? So some case, if you say that this image, if I given that to the model, a woman is holding a cat in her hand. So this is the actual model output. So the model is telling that woman is holding a cat because of the dress, because of this nature. It's saying that it's a cat. It's a wrong, right? Next one, a person is holding computer mouse on the desk. Again, it is wrong. Look at this one, a woman standing on the beach holding a surfboard. So as we said that we can make easily, we can fool the AI system, because similar kind of images are given for the training earlier case, and the model identified that as a surfboard. Now it's telling that it's a surfboard. So like that. So here, if you say that a man in the baseball uniform throwing a ball, he's not throwing a ball here, right? So the model is telling that he's throwing a ball. So now these are the image captioning failure cases. Now the main question is how to improve the model, how you identify that where the problem is. Say for example, if you say that here I'm telling that a woman, yes, woman is there, is holding a cat on her hand, in her hand. So I want to say that why the model says it's a cat. The model can say that yes, I have seen this particular portion and then I matched that with a cat. I need to know this information, because if I know that why the model is wrong, why the model says that this is a cat, there is, I'm saying that nowhere cat is there. Whether my model wrongly says that this portion has a cat or this portion has a cat, I don't know. If I ask the model that which is the cat in this picture, if model will highlight and then it will say that same model. That is called attention model. We are going to discuss the next one. So I can easily understand, I can easily correct my future examples. So before giving to the model, I will easily understand that, okay, this kind of cases this model will definitely make a mistake here. I don't know why the model says a surfboard. So it may misunderstood, but it's saying that a woman standing, the woman is not standing, right? So those things we can easily understand with the help of image attention. So the image captioning, there is something called image attention. So I'm not deviating anything from the NLP, because this is also the NLP, the image attention we are giving to the image. But the output, if you say that the output is something like the input is a cat, and the model will say that where the cat is. The input may be the ball, the model will highlight and then it will say that where the ball is. So it's a combination of the NLP as well as image processing. See that example, whatever I said, that image attention. So the woman is throwing a frisbee in a park. This is the output the model is given. I want to know that what is frisbee in this image. So I'm underlining the frisbee. It means that I'm giving a frisbee, I'm marking frisbee, and then I'm running the model again. So the model blurred the portion why it generates the term frisbee. Say for example, group of people. I underlined the people. The model highlighted that. You can see that some blurring is there, this portion, right? It means that model telling that I have decided the dog based on this particular portion of your image. So where is the stop signal, I'm asking. Instead of that, I'm saying stop. Why a stop is, the model is telling that this is the stop. Interestingly, the last output is say that a giraffe is standing in a forest with the trees in the background. I'm telling about the trees. Model exactly identifies the tree portion and then it highlighted. It's blurred. White is the actual thing what we want, right? It blurred the complete trees, right? This process is called image attention, where you can use this image attention to improve your model further. So the same concept, as I said, that always the domain, between the domain you can exchange the ideas. That's a major advantage of the ML as well as the deep learning models. Yeah, when it comes to here, the image attention, the similar kind of attention we can, based on this attention only, people come up with a model called a neural machine translation system, whatever sir said that. So there is a mechanism to say that suppose you are translating a language, you are translating the language English to Hindi. Say for example, I found one wrong Hindi word, but I don't know why the model generated this Hindi word. If I go back with attention, if I link this with attention model, if I say that why it's generated this particular Hindi word, the model will mark the English words. Yeah, you see that there is an English word like this. That's the reason I have generated this Hindi word. So I can compare my model. I am getting the reason for that. This is a stepping stone for explainable AI. So now explainable AI also emerged as a interesting topic where a lot of researchers are working on it. This is the stepping stone for that, the attention models, and particularly the image attention as well as the attention in natural language processing. So it's telling that, right? So why the model generated this word? That's what we want in explainable AI. So as I said that the attention explainable model with respect to the NLP, I have an example with respect to translation. If you see that, so I have a sentence. So the animal didn't cross the street because it was too tired. The sentence is there. So one more sentence. The animal didn't cross the street because it was too wide. So here I have two, that the sentences look like same, but the first it refers something different. The first it reference, it was too tired. It says about animal. It was too wide. Animal cannot be wide. So obviously I'm talking about street, right? So this information can be captured with the help of this self-attention mechanism. You can see here that, so if I pause the word it, and if I'm asking that where I can map this it, the the darkest one means highest association. It's associated with animal. But if I change the sentence slightly, I haven't changed the complete sentence. I changed only the single word. How the single word impact? If you see that after changing the single word, if I'm asking that the relationship or the association with the it is street, it moves to street. Earlier the model says that said that it's animal, the it is. Here the it is street, right? This is what the attention.
Sir, can you hear me? I'm not able to understand what you're speaking. Can you start the
Yeah.
attention aspect once again?
Okay, fine, sir, no problem. Here if you see that, so I'll clear this once again. One second. Yeah, so here I'm talking about the attention, self-attention mechanism. Say for example, that there is a two sentences are given here. So where I want to understand the attention, self-attention for each word. Say for example here, the animal didn't cross the street because it was too tired. It was too tired. Next one is, it was too late. So two different sentences. The sentence is different because of the last word, right? It was tired, and other one is it was wide. The it represents, as I'm saying tired, actually the it represents animal here, right? Here it was too wide, I'm saying that. This it represents street. So this information, if this kind of, this is a, we'll call it as anaphora resolution. So this can be resolved with the help of self-attention mechanism. You can see here that in the case of self-attention, so like earlier case, I'm pausing the word dog and I'm asking that where the dog portion is. Here I'm pausing the word it, and I'm going to say that which is a suitable word or associated word for this particular it with respect to this sentence. So the model highly correlate with the first word, the second word, animal. Same sentence, similar sentence, and when I go for here, it, I'm saying the same as I have that different sentence ending wide. The model is going to street. So that is a self-attention. Where
Saying
you
that
are,
remembering the previous state using LSTM or something.
yes, correct,
RNN.
sir. Yes. So even if you have that, even you don't want a multiple languages, we can use this for multiple language translation also. Even if I give a single language or single sentence, there is a high chance for a model to identify the which is the associated word or which is the relevant word to this. So I hope you are about the dependency parsings, right, sir?
Yeah, because it's a pronoun here, and then the pronoun must be referring to a previous noun, and the
Yes.
previous noun was animal.
Animal. Here, if you see that the second one, as I'm using the word white, the previous noun is it's going to street. The wide and the tired only deciding here.
Yes, yes.
Here, as it is a tired, then I'm telling that it's not a street. I'm telling that it is animal. As it is a wide, this is street. Street
Yeah,
and
how does
wide
it,
will be close.
we are storing the previous, we are also storing the relationship between the
Yes, sir.
verb
Yeah.
and the
Tomorrow
noun
we are
also.
going to see something called the word embedding. That is a base part actually. So where we are going to see that how here the simple the understanding perspective. I'll just to say that the animal and tired, animal and tired, or related words. The relationship or the similarity between the animal and tired is more compared to street and tired. Right, sir?
That's because the verb tired, getting
Yes.
tired is related to only living beings, and animal is a living being and all that. That kind of
Exactly.
contextual information will be this already stored
Yes.
previously.
No, we are not storing the contextual information. That is the beauty of the model. The model understands this context based on huge number of samples.
Yeah, so it has learned over the training received from the huge number of.
Yes, yes. So tomorrow we are going to see something called the embedding, embedding and vector representation, where you can see that the animal and tired. If I take a dot product between the animal and tired, I'll get a high similarity score. If I give animal and street, sorry, animal and wide, I'll get a less score. So tomorrow I'll take the same example and then I'll just explain that. I'll just note down the example. Animal wide.
It's because the previous corpus, which was used for training, had those words occurring related to each other in various data instances,
Context.
right?
Yes, yes. Street, tired.
So same thing we could have achieved if you identify the noun or verb, whether it is a living being or non-living being, and had we stored that, what are the verbs which are relevant for living beings. That is the conventional method without
Yes,
this
context based
probability.
one, or we used to say it's a semantic role labeling, right, sir?
Correct, correct.
Yeah. So it's a purely the linguistic based model.
Yes.
Yeah. So now we'll just move to the next one. So
Sir,
yes, ma'am. Yeah, Anusha. Yeah, please.
yeah, yeah, sir, can you please tell me the difference between the self attention and 8 attention heads? Means how it is different, and
8 attention head.
where we applied the attention heads, and where it is suitable to apply only self attention.
Yeah. So actually the 8 attention also, you are talking about the 8 attention means you are talking about the transformer model. Am I right?
Yes, yes,
Yeah.
sir.
Yeah, the transformer model. That same thing. This transformer model, we are using the self attention, but we may not achieve the attention in the one layer. That is the reason if you see that I have given here that multiple layers are needed. This itself a transformer. Here I have given that, right? So from
Yes.
5th to the 6th layer of the transformer. So the transformer have the multiple layers where we'll have the intermediate outputs, but when you go for the more than 6th layer, after the 7th layer, I mean 6th layer or the 7th layer, the 8th layer, after learning with the multiple layers, we are getting this meaningful information. If you are trying with the first layer or second layer, the basic LSTM layer, and we won't capture this association. The model may not capture this association.
Means, sir, you are telling me that means after some number of layers we should put attention layer to get
No,
the
no,
better output.
the architecture itself, it's like that we have this all layers are only the attention layers only.
Okay.
Each layer having the attention weight, the transformer.
Sir, can you please repeat your voice?
Okay, so I'm saying that the transformer architecture, if you say that transformer architecture consists of the full attention layers. Each layer we are introducing the attention layer with respect to the position encoding.
Okay.
So first layer itself, we are starting with the multi-head attention only, masked multi-head and the multi-head attention. Then only we are going to the upper layers. So the attention here, the point is the single attention layer may not be enough. So you want multiple attention layers to capture these kind of associations.
Okay. Sir, can you tell me one more thing?
Yes.
Uh, Query key values. What are the main role behind this? Means query
Yeah,
key values.
I can tell that actually, but now we are not talking about that actually. So maybe the other participant may get confused, right? So let me finish it and then at the end, can I say that?
Yeah, thank you. Thank you.
Yeah, so you are talking about the pure attention model, right?
Yes, sir.
That
Pure
is
attention.
closely related to the deep learning part. Anyway, I'll tell that actually what is that, but at the end I will discuss that.
Okay. Okay.
Right? Yeah.
Okay. Thank you, sir.
Yeah. So I'll go to the next slide. So the generating sequence. Fine. So now we are talking about the NLP with other applications. So where we are talking about the image, we have seen that, and self-attention, we have seen that. This is also kind of image, but if you see that it's a handwritten image. So now the future Gmail may have the option like how now we are choosing that we are sending the email in Times New Roman and other things, right? The future email may be in your own handwriting. I don't know why they are not doing that. It's a they can do it in a simple way. They can maybe the future they may have the plan to do that. There may be option for your future email will be in your own handwriting. So if I take you to write something, if I take your handwriting of one page, then I can easily generate your handwritten sentences. So the automatically handwritten stroke generation. So this model is a base for something called AlexNet. So AlexNet was the model behind that for generating the sequence. So these are the machine generated sequence. So machine generated based on the awesome recurrent neural networks, and other things. So where you can ask them. Here my point here is the generation. The model is not only generating the text, the model is generating the similar images or similar graph. I can say that these are the kind of, I cannot say it's a graph. I can say this is a fine. It's a figures. So the similar figures also it's generating. That's what the future GPT models we are going to see the images on it. Fine. So that's one application. So the next interesting application, there are a lot of researches going on this visual question answering. Very less number of people are working on this. So again, this is related to NLP plus the image, but this is something like a synthesized one. There is a famous data set called Clever data set. So you can see that this is important with related to logical reasoning. We are making a mission to logical. So so this is the base. This is the based on logical reasoning. So we are giving some natural language text as an input. So where we are questioning the model. The model is answering the help of logical thinking. Say for example, I directly go to the example. This is synthesized one. As I said that the image is given, and then we are asking question: are there an equal number of large things and metal spheres? The model should read the image and the model should understand the image and model should generate the question. Generate the answer. What size is the cylinder that is left of the brown metal thing that is left of the big sphere? Right? The similar fashion only the LLM and everything is based on this only. But here we are understanding something from the images. Here the different color is there, right? Different color represents the different attributes. So say for example, one talks about the count. So one talks about the count. Say for example, what size you are asking about. You are asking. I can say that you can asking the attribute, or you are asking left off. You are asking the some spatial relation. You are saying that, and you are saying comparison. Say for example, you are saying the brown metal and the brown sphere, big sphere. It's kind of a comparison. So those things the model will understand that. Based on that, the model will take decision. You can see the last question. How many objects are either small cylinders or red things? small cylinders or red things. So how many? I'm asking the count. So small cylinders or red. So I'm telling the attributes here, right? Its adjectives are there, where your linguistic knowledge or the post tagging plays a major role. Small cylinder. So this is adjective. Red things. It is adjective. So I can easily say that if adjective is there, it's something. It's an orange color, right? The orange color is talks about attribute. So adjective, we will say it's attribute, right? So it's attribute. So like beautiful boy, it's attribute, no? So same thing, small cylinder, red thing, brown metal, metal cube, large thing, metal sphere, small red sphere. All these things are attributes. So you can identify the attribute with the help of adjectives. So using this, the model is answering that. So there are some systems are available with more than 85 to 90% accuracy for huge data set. But here the one important thing is, again I'm repeating, the data set is the visual reasoning data set, but it is handcrafted data. So we have the human generated the image purposefully. They taken the image like this and then they post the questions, they given the answers, they train the model. So if you're interested, check this data set, Cloud data set. Next one is same visual question answering. You can see that. So earlier, as I said, that it's based on the synthetic image. Purposefully, I have, because my purpose here is to make a visual reasoning model. So I made a data like this. But here, if you see that visual question answering, so again, the text question, NLP text question I'm asking here. So I have given an image like this, right? I'm asking question, where will the driver go if turning right? So the answers are given. So the model, the options are given. I'm asking the model should, based on the image knowledge, the model should select the best answer out of it. So here, when was the picture taken? So based on the dress and the cake and other flower, and model understands that this is during a wedding. So again, I'm repeating, there is no hard and fast rule to give 100% accuracy. But the models are giving 90% accurate, but 90% accuracy itself it's a very good stepping stone for this kind of question answering system, visual question answering system. So there are some mistakes also. If we see that who is under the who is under the umbrella, it's a two women. If you're asking who is holding the umbrella, also sometimes the model will say that it's a two women, right? Because you haven't any you don't have the sufficient options for that, right? So the other important thing is the options. Model is restricted to choose only from the option here. You are not allowing the model to generate something new. You are asking the model to select from the options.
So before selecting the option, there is image recognition done previously.
Correct. Yes, sir.
Before.
Image recognition will be happening there. After that only we'll come to this image. So now there is something called visual transformer. So visual transformer, like how we are having the bird transformer. So like their image processing, they are having something called visual transformer. The interesting fact of the visual transformer is it's learned on images plus text. The combination of both, where in the visual transformer you can pause the images and text the corresponding text as the questions, and you can expect the model to suggest some answers. Right? Shall I move, sir?
Yes, proceed.
Yeah. Fine. So anyway, this we will discuss actually later. This one is end-to-end memory network, the continuation of the question answering. Again, the synthetic question answering. So this is a pure question answering. There is no image involved here. So, but again, I'm saying that it's a synthetic question answering. So these are the stepping stones. I can say that the earlier there are some models like this. Using these small models only, they're now currently they build the large language models. They try to solve all these problems separately. They've integrated all the problems in one system. They are calling that as a LLM. You can see here that I'm giving some scenarios. Mary moved to the bathroom and John went to the hallway. And the question I'm asking, where is Mary? So the model will search from the two scenarios it's given already. The model will search and the model will find out it is true. This is a very simple network. So there is a complex question answering is there. the end-to-end memory network. If you see that, I'll just quickly explain only one story and we'll go further. You see that how the model is brilliantly taking the decision. So there are some fact question types are given. I have taken the type example type basic induction here. So I'm telling that brain is a frog. The first statement. Second statement, Lily is gray. Brain is yellow. So brain is a frog, brain is yellow. So you can link that. So frog is yellow, something like that. So the next one, Julius is green. Greg is a frog. Now I'm asking, what is the color of Greg? So the model should understand that the answer is, with respect to the question, the model first should understand that this is nowhere related, Lily and Gray. And Julius and grown is nowhere related. Other three sentences are related. That we are calling it as a support. Yes, yes, yes. These are the supporting sentences. Now from here it's going to backtrace something, and the hop value is also given. It's a probability. If you just consider it as a probability value, Greg is a frog. From there I have the word Greg, and then I'm connecting that with a frog. Fine. Now the next sentence, I am searching that there is no frog here. Here I'm having a frog, right? So I'm relating the frog with a brain. And when I search for the brain, I'm telling that the brain is yellow. So the answer what I'm expecting is answer should be yellow. So the prediction also the yellow. So the model even, so here again I'm telling that this is a synthetic one. So there are set of people, set of researchers sit and then they design the questionnaires and they train the model to work initial level. So once the model trained for this synthetic data, so slowly they will give the real-time data. Say for example, they try to cover everything. That's what they are having some 20 different stories actually. So based on the 20 stories, 20 different, I can say the 20 design patterns or 20 different language patterns, question patterns. They're training the model for different patterns. So if I give some input to the model randomly, it may fall under some pattern. The model knows the pattern very well, and then it know how to solve also. So model will solve in that way. So that's a that's the
Sir,
idea
here
behind this. Yes.
associating frog as yellow because Brian is a frog, but
Yes.
Greg need not be yellow. There may be multiple colors for frogs. This is general intelligence or common sense, which is not only within the given limited information.
Correct.
There is a difference.
Yeah. The given, as you rightly said, that the given the given task is actually I have to answer based on the given samples or the given scenarios. This is the information they are given. Salim Saik, you are asking, you are having some question or some noise? Yeah. Salim? I think you are talking somewhere, I guess. Fine. So we'll continue then. Okay, so before going to that, I have a few more slides to explain. So I'll do one thing. I'll just take a small break. So Kishore, sir, are you available?
Yes, sir.
Sir, now 5:02, sir. Actually, I'll take 10 minutes break and then I'll be back, sir.
Okay, sir. Okay.
Yeah, sure. Participants, you just wait for 10 minutes. I'll back and then we'll continue this.
Okay, sir.
Yeah.
சார்ஜ் போடு. யாரா மணிலின்? மணிலின்னா யாரு? யாரு? அப்படியே ஈரமா போட்டிருக்கியா? துவைக்கு போட்டு பாத்ரூம் அப்படியே போயிடலாம்னு நினைக்கிறேன். அதை அப்படியே துவைக்க போட்டோம். நம்ம அம்மா அதெல்லாம் பண்ணக்கூடாது. அழுதான் சின்ன வயசுல ஆட்சி ஒண்ணு தெரியுமா? ஓடக்கூடாது. வீடு போய் இருப்பாங்க. வெளியில போக முடியாது. வெளியில ஓடி கரெக்டாக இது பண்ணி வெளியில ஓடி இருக்கிற பிளான் பண்ணி எங்க அம்மா அழுதான். அதான் இப்ப டேடி அங்க இங்க இங்க அங்க இங்க பால் முடியாது கேக்குதா இருக்கும் எதுவும் அப்ப
Yeah. Hello, Kishore. Can we start? Hello, participants. Am I audible?
Yes, sir.
Yeah, we'll start, right? Yeah, fine. So we have only 45 minutes left. So next, I think 20 minutes I'll complete this. Maybe 15 to 20 minutes I'll complete this. Then we'll go to some demonstration. Yeah, am I audible, right?
Yes, sir.
Yeah, I'll continue. Fine. So now we have seen hello. Fine. Yeah. So we have seen some applications. Rohini, can you mute yourself? Rohini, Dr. Rohini. Fine. So we have seen the different image plus NLP applications. So we have few more things actually to explain that and the neural machine translation. So before that, I'll just show that the one final slide about that how we are capturing this or how we are combining this image and natural language processing. This is the person whom I said, Andrej Karpathy, so from Stanford University. Now he is with X. X means a Twitter. He is with a Twitter. Fine. So the dense cap, if you see that, if I'm giving the image, there are 4 different cases. The first case is, can say that one axis is the whole image. I'm processing the whole image this side. Another one is the image regions, right? And here I'm talking about a single label. Here I'm talking about a set of labels or sequence. So the complexity level will increase if you go sequences. If you ask me to generate only the one label, whether cat is there or not, it's easy for me. For NLP also, it's easy to say that the word cat. And here it's a sequence, the complete sequence we are generating. So it's a complexity level is increased. Label density. So if I give only the whole image, then I no need to go for a region, I can analyze that. But here if you see that you want some information about regions also, some sections in the image. So that's what the complexity level increases. Okay, as the 4 examples, the first example we'll take. First example is a simple classification example. Here NLP is may or may not required. I'm giving a small image and then I'm getting the output like cat. This is a simple image classification. You don't want NLP at all here. So you can go for object identification or object classification. Fine. The next one. So I'm going to take a single whole image and I'm going for a captioning, but I don't want a single label. I want a set of sentence where you want NLP. That is what we are saying image captioning. You have a image is given and I'm getting something like a cat riding a skateboard. So that text I have given. So it means that, as I said, that the NLP is involved in here. So without NLP, we cannot do this captioning. So same image, single image, there is no regions. So I'm generating the captions. Fine. Okay. So the next one is the third region. So where third image, where I'm going to talk about regions. So I'm not having a multiple regions. So I'm having only single or not. I mean, 1 or 2 regions. So I'm having here 2 regions. So the first region I'm telling that is cat. The second region or second object, the overlapping also allowed. I'm telling that this is skateboard. Again, I'm telling that this is we may not need NLP here, but we need NLP in the next one, dense captioning, where for the each region, there will be multiple regions in the image. Each region, I want explanation, or I want a set of NLP. What machine understood that I want the explanation or description in NLP. Say, for example, the earlier one is what is happening in the image. That is a captioning. A cat riding a skateboard. This one, if you see that brown hardwood flooring. I'm telling about this flooring. Cat riding a skateboard. Obviously, that is also one part, one segment of captioning. Skateboard with red wheels. I'm going minute details about the objects. Or cat hereafter, so far we are telling about cat. I'm telling the attribute of that. Orange spotted cat. So those things comes under something called dense captioning. So this is other interesting area. If you are really interested, there are data sets are available, open source data sets are available. Just you can download from Karpathy website or Stanford websites. So this is the dense cap output. So you can see that there are some mistakes also, but if you can see that floor is brown, man wearing black shirt, chair is brown. See that how minute its model understand that the chair is brown. Man with the black hair, white laptop on a table, man wearing white shirt. That it's making some mistake here. I don't think it's a white shirt. And a sign on the wall, something like that. So how they are identified that. So as I said that it's a combination of image captioning plus the object detection methods in computer vision. So from the object detection they are used this is the well-known this is a well-known object detection method. So I can say that uh, this is a kind of base model for the object detection. They are giving the object and then they're identifying that the object name. Now they are linking that with the image.
Sir, you are muted.
I don't know. Someone is someone is muted. Fine. Okay. Just now, right, Anusha, or I was audible before that, right?
Yes, sir. Up to object detection, it was audible, and then.
Fine. Yeah, I think someone unknowingly muted. Fine. Okay. So yeah. So the object detection and the next one is the image captioning. So object detection, as I said, that this is a traditional mechanism of object detection. So there are a lot of architecture for object detection. So image captioning also there. So they are merging this object detection and the image captioning, and then they are coming up with the answer like, so say for example, stripped gray cat, cats watching TV. So like that. Fine. This is also the other output. Here I want to mark only some issues in that. So for example, man wearing a black shirt, but man wore a red shirt only, right? So, and I can say that shadow on ground. So I'm not seeing any shadow, whether it's a really, we don't know whether it's a shadow or not shadow of the elephant or not, but the model is telling that shadow on ground. So like that, there are some issues also with this dense gaps. Fine. Now we are coming to that, the one interesting final architecture of NLP. It's called a neural machine translation architecture. So this is based on a word representation as well as the recurrent net. You can see that what is happening in the neural network, neural machine translation system. That is a translation model where English is given and French is given in other direction. So we are going to translate the French to English. This we can call it as a encoder decoder model. The interesting thing in this model is it doesn't bother about the usual machine learning or models are the input and then output are dependent. Say for example, if you have 5 inputs words and then you can expect 5 output words like a post tagging or any or something. But here MT is not a model like that, and MT is completely different. You may have a 5 words as an input and then your output may be 20 words, right? Your input may be 20 words, or output may be 3 words. So possibilities are there for some certain languages. So the model, the encoder decoder, the beauty of encoder decoder model is we used to call it as a N east M model. So N input and M output, N input words and M output words. The first step is it's a one-hot encoding. So one-hot encoding means the complete vocabulary vector will be taken. So and the particular position of the economic will be 1. All the remaining position will be 0. So from this 1, so we are going for this word representation. So that is what we are going to see tomorrow. Completely, we are going to see about word representations, word, or we'll call it as a word embedding or word vectors. So all are same: word representation or word embedding or word embedding or word vectors. All are same. So after getting the words one-hot representation, we are converting that into a vectors with the help of word2vec or glow or fasttext. Then we are giving here to the recurrent state. So where we are using here the LSTM. So here it's LSTM is used. So sometimes some architecture we suggest to use for by LSTM model, where if you see that here it's going in only one direction. So by LSTM means it'll try to push the information in other direction also. It will learn. So like how you are getting the red color context layer, this is called a context layer. Your input data you are converting into the context. Same thing in a bidirect. If you go for a bi-LSTM, you'll get a left context as well as you'll get a right context. So what does it mean is I'm getting all the information I'm learning for the language E from the language English, and I'm storing it the information here. So using that information, complete information, I'm passing that information to the next recurrent state, LSTM state, and I try to generate the words in other language. So remember, I'm generating the words. Finally, as this is connected with a recurrent architecture, so the model learns the structure also. So that is the reason we are getting some meaningful output. Otherwise, we'll get some output like a different words. We'll get that we won't get any meaning. But as if you see that the networks are connected, we are using the recurrent neural network as the model is for sequence modeling concept. So we are interested in identifying the best sequence also. The model, when the model before chooses the second word, the model will say that you can see here first word is selected. The first word is giving as an input here. 1 second, I'll clear this. Yeah, the first word I selected the word the, say for example, the output. The second word, whatever I'm going to do, whatever I'm going to predict, that should be the appropriate sequence, and then it should be followed by the earlier word. So here I cannot go for the, then it means that wrong, right? So the information, whatever I learned, I have extracted earlier, that information also passed here to generate the next word. So this is the next word. This is kind of this particular small part is language model, what we discussed, that next word prediction. So from so I'm going for the next word. So the model will say that the economic, the next one maybe the economic growth, something like that. So the each input, once I generated the output, I'm giving that as a input to my model. I'm giving that as an input, generating. So like that, I'm forming some meaningful sentence. So this is the base model of neural machine translation system. So very few people are working in the Indian context. Definitely, we want more hands to join together to work on Indian context to come up with a good neural machine translation system. The same thing here, as I said that here, as I said, it's a yes, ma'am. Yes, Anusha.
Sir, suppose we have an input of 5 or 6 words. Then
Yes.
in the encoder side, do we need 6 number of layers of LSTM? Means any RNN?
No, here actually the LSTM is only one LSTM cell. LSTM is only one. Where you are having the, we are having the LSTM cells. These are the cells. This is only one recurrent state. I'm telling that. No, this is one LSTM. Based on your input, if you are having 6 means, it will have a 6 units. So it's not 6 LSTM. So it's a one LSTM. It will take your first word. It will pass to the next word. It will learn some information. It will pass to the next word. It will learn some information, pass to the next word. Finally, whatever information I'm having is, I'm telling that this is a context, the red color mark. So the understanding here is the context will have complete encoded information of your input text.
Okay.
So irrespective of your size, if you have a 6 words or 7 words or even 20 words, you'll have only one context vector.
Okay.
Right? Yes, ma'am.
No, thank you, sir.
Yeah. So that information, as I said, that this information consists of the complete information of your input sentence. So when I generate the sentence in the other language, I'm using that information in each and every place. You can see that even I'm generating the first word, I'm using that whole information I'm using. So whole information I'm using, I'm generating the second word. Because as you know that the empty, we cannot say that the first word is matched with the first word is matched with the fifth word or like that, right? The complete context should be put together and then the information should be generated in other sentence or other language. Fine. So the earlier example we have seen a machine translation, same example. Earlier example we have seen a English in one side and other side we have seen a French. I suggested you can go for Indian language to Indian language or English to Hindi or Hindi to South Indian languages. All things are possible. But now something like a English to English, I want a system. The same architecture. Here I'm giving English, here I'm giving English. I don't want to give a same English sentence. So here I'm going to give a query. And here I'm whatever English is there, I'm telling that these are the answers. Or why don't I build a chatbot for this? If some query is asked related to something related to railway or something related to tourism or something related to academia, colleges, or some query related to the government policies or government schemes. So that is the input, and I have some output as a question. So say that this is the stepping stone for the current open AI models, chat GPT model. So this is a chat model. The architecture of the chat GPT also is similar to this. Only the vector, whatever the way how they are converting into the numerical form is different. And the generation side, as they have the huge corpus, they are using the probability model, probabilistic.
Previous slide, can you explain how the vector is getting constructed?
Tomorrow the complete class is for how the vector is going to construct, sir.
Okay.
Word vector. Yeah, tomorrow is that a word embedding, the neural language models. So where I'm going to cover that. So the earlier mechanism is, as you know, the one-hot representation or the TF-IDF based model. The tomorrow's complete one is a neural language model where I'm going to talk about word2vec and GLOW, Stanford's GLOW, and fast text, all three. Here, so as I said that this is a kind of like a translation from English to English. So question is given here, how are you? The answer, I am fine, is the answer I am expecting. Same architecture you can use for any purpose. So now the large language models using this similar kind of architecture where question is asked, where the model is giving some answers. Yeah, this is what we discussed. I think you'll some user input is given under this complete information.
You are muted, sir.
We're not able to hear any voice. Hello, sir. No, we're not able to hear your voice.
I don't know
Another-
what is happening. Someone is muting. Yes, sir. Is it? Can you hear me right?
Yes, sir.
Fine. Yeah. So the Bengio. So if you see that whenever I'm telling that, so there are 3 persons in when you want to learn the complete learning, deep learning, or the NLP things. There are 3 persons. So one is Christopher Manning, who is an expert in the NLP, Christopher Manning. And the second person with respect to the NLP plus the machine learning, I can say that this guy, Bengio. So we can refer his papers. The second guy, I can say that it's a Bengio, and then that Manning from the Stanford. So Bengio, and then the third guy, I can say that the Karpathy. Now he is not only in NLP area. He now, as you have seen that because of the AI, people started using, and the NLP researchers are moved towards the machine, moved towards the computer vision and all the robotics field and other things. So I can say that the Karpathy also. So these kind of researchers you should follow. Actually, you should see that what kind of research papers they are publishing, what kind of research projects they are working on it, and other things. So before you choose some topic. So that is a kind of a state of art models. Yeah, this is what the same thing. Hello, hi, and other things. Fine. So now that the same neural machine translation system, but here I want to know that, say for example, I generated my output of the French is this one. Now I want to say that why I got this sentence. I want the link between this economic or model is completed, model generated the sentence. So, but now what I want is I'm taking one random output economic, saying that why it's generated this. So my model should say is that I generated this economic because there is a word economic in English. This link, how I'll get the link? I'll get the link based on something called the attention mechanism. So where I'm introducing this attention, you can see that there is some annotation on position vectors of the each one. Attention mechanism is it's like a kind of feature selection. Here each word you can consider it as a features. I'm going to feature importance, not feature selection, feature importance. I'm going to find out that which feature plays a major role to identify the word economic. So when I'm saying that this particular neuron or this particular unit of I'm taking that, so where I'm checking the attention weight with respect to this, for particular attention weight, say for example, as this economic weight is the first one, the attention weight, the sum of attention weight should be 1, as it's like a kind of softmax function. So I will get something like a 0.7 for this particular layer, for particular unit. Others values will be a 0.1, 0.0, something very less compared to the 0.7. If I see that where the value is maximum, I'm just coming back and then I'm tracing it where the value is maximum, I'll get the term economic. So this is just, as I said, that this is a stepping stone for something called explainable AI models. Yeah. So this is, I think, yes, sir.
What are the 0.7 other things?
0.7, I'm saying that's a probability, sir. Attention weights.
Okay.
So if I say that in a phrase-based translation system, we'll have the option of probability values. The same thing in a deep learning models, we have it as the attention weights. Say for example, if I say that the economic, if I got the word economic in French, but if I come to know that, if I want to know that why I generated this sentence, the model will say that this is a 0.7 probability for this. This may be the 0.1. It means that the growth is the 1% of the growth is influenced for us to generate the word economic. The majority is from the word economic. So I can build a kind of as a part of output without giving any dictionary. I can ask a model to come up with a dictionary based on the attention weight. But the dictionary may not be the human vetted dictionary like what we are having as a knowledge base, but I can say that tentatively that will be a automatic way of generating some dictionary, particularly if you go for low resource languages where we don't have any language resource or we don't have any dictionary. So this kind of model can build some base model of the dictionary. Yeah, so we are coming to the end.
Even to calculate, it
yes,
should
sir.
have known that there's a word called economic in French.
Yes, so from the training, the model will learn that, sir, actually. It's a part of a neural machine translation system where we are giving, as you aware that where we are giving the parallel corpus, right?
Yeah.
For training.
Yeah. We could have achieved through dictionary also, but without dictionary through training, it is achieving.
Yes, correct. We can use as we discussed already that if you go for Indian languages, because why it's performing good for English, that is a one important mistake what particularly the Indians are doing. Even it's a data-driven model that is adapted. The model is designed, customized for English. We don't know that it's customized for English. Why it's working for English is, again, I'm repeating, English is good in sentence. So the sentence consists of all the, if you take a complete sentence, you'll get the morphology, all the information. But our languages want some extra resources. Definitely we can think about that. I don't know whether we have the paper like that or not. Influencing or leveraging the dictionary for the neural MT, or leveraging a kind of WordNet, multilingual WordNet for neural MT systems.
Yeah, multilingual WordNet for Indian language is already available.
Multilingual WordNet is available, sir. I'm saying that the impact of multilingual WordNet in neural MT system.
Yeah, it will definitely improve, and accuracy and less training will be required, no sir? Because
yes,
because otherwise it has to depend only on if you give small training, then it will fail. The translation may flop.
Yes.
So that's, I think a hybrid approach will be better, sir.
Better, yes, hybrid approach. Fine. So now I think we are coming to that end of the attention thing. So So where that the current research is going, this is a stepping stone for why I included this, the old one. But there are something called the temporal information also people try to capture from the NLP. So where the history of the text, how the language, not exactly how the language evolved. I'll say the example. Say for example, we discussed about the social media. There is a chance that with the help of social media text, we can say that how the person, I mean, whether the person is in depression or not. Here, I should not take a decision based on one single post, whatever he has given. He has posted in a social media. So the decision should be based on set of posts, right? So it's difficult to take the exact information from the single post. Rather than that, I'm just analyzing some temporal information as a period of 1 month of, I'm just analyzing his social media text, and then I'm coming to the conclusion that where the reason why the temporal information is important in NLP, you can look back your model and you can say that, okay, fine, you understand that the guy is in some depression or some stress or something. So you can go back to your model and then you can find out the reason for that, right? That is important. So the model, whatever we are building, the model should not be like the blind model or black box model. We should ask a model, as a layman, you should ask the model why you are telling that the person is having tumor. So why you are translating this word. So why you are telling that I am in a depression. So the model should go back and then say that, or I can ask that not only the why, what is the reason for that. So the model can analyze the previous text with respect to the date and time, and then the model can come up with that. During this particular duration, he had some accident or something. That was the reason he becoming like this or something like that. So the psychotherapist or the any or the parent or the teacher or the advisors will get an exact reason for why the person is in that particular position or other things. There are less number of research in the direction. If you are interested, you just include that. This is related to the temporal structure, but here they used the videos, as the video is also a kind of temporal information. From the video, they have applied this the same captioning concept. So the each word, the color represents that. If you see that the man represents that, here the first frame, the man information is there, and women information also high. Talking, it's look like they are talking, so that information is high. The road, somehow the model missed the road, so that's what the road attention or the information, the score for the road is less. So the next one, if you say that exactly, it says that they are not talking, but the model, model says that they are talking. Model have given less weightage to man. Here, if you say that, again, less weightage to the man, but somehow the model identified the female, and still it's saying that talking, and then the model identified that road. So this is what. So it's not the video captioning is happening with respect to only one single frames or single images. You can do it for the set of, you can do it for the videos. It means the set of frames also. But the accuracy of the model is not up to the mark, the earlier model. But I don't know, now they have come up with the interesting model. Maybe now the model may be updated because it's a little bit old one. You can see here that, so the model says model says someone is high here. Someone is frying a fish in a pot. I don't think it's a fish, but the model is telling that it's a fish. So here that frying is high. So something, okay, sorry, the reference itself, sorry, the reference is frying food, but the model is identifying it as the fish. The model is more telling something about the additional information also, it's giving pot. Fine. So with this, I'll just anyway, the word vectors, I'm going to talk this word vectors, the continuation of these two slides and other things I'm going to talk tomorrow only. Anyway, I'll take 10 more minutes to explain some coding actually, because 2 days I said that I thought of giving the demo, but I'll just take some code and then I'll explain it. I don't want to explain the step-by-step things. I'll just say what is happening in the code. So if you're interested, I'll hand over the code also to you. So you just run it and then try to understand it. So my humble request is don't start anything from scratch. It doesn't mean that I'm telling that you take someone code and then you just use it. No, that is also not good. So I'm saying that there are a lot of resources are available now. Make use of it, and you see that how you can update or how you can develop something new from that. So your starting step of the research is, it should be like someone where they ended the research. You should start from there rather than starting from the ending. That's the reason I'm telling that. I just explained the code. If you want, you contact me or you contact Kishore. I'll hand over the code also, and you work on it. You see that after working on it, we have discussed a lot of new directions actually. So you see that anyone, you just identify that, and then you just see how you can, the existing code, you can modify it, and then you can proceed further. Fine. So the tomorrow's things, I'm going to continue with this one. So far, I'll just spend some 2 minutes in this slide and then I'll complete. We have seen a lot of applications so far in the NLP for last, this is the third day, right? So where we are talking about sentiment, entity, translation, topic, everything we have seen that. But the traditional architecture will be like this, where we have a separate tokenization, separate post tagger, separate stop word removal, separate feature extraction for English and Spanish, Arabic separate, and other things. Now, the deep learning, when the deep learning comes into picture, the machine learning comes data-driven model. So everything is clubbed into the deep architecture. So documents, there is something called a dense embedding. This is what we are going to say in tomorrow's presentation. This is the architecture for any text classification application. So documents, you are converting the documents to the dense embeddings through some neural network. After that, you are having a few hidden layers to finally identify the output or learn the output. This is the complete architecture for any classification problem, starting from entity recognition, or even for post tagging or sentiment analysis, or stance reduction, fake news, hate speech, all applications, whatever we discussed yesterday, all text categorization or text classification application. This is the basic step. Data, dense embedding, pre-processing is the default one. Data, dense embedding, machine learning, output. That's it. So tomorrow, anyway, deep learning, as it's not our scope, I'm not going to talk any deep learning architectures as a part of it. Tomorrow, I'm going to cover the dense embedding part. Once the dense embedding is over, then we'll go to large language model. Now I'll stop my slides here. So I'll take 10 more minutes. Now 47, I'll take up 10 or 8 more minutes. I'll just take one sample code, and then I'll just give some idea about that, how to create the NLP model. So, or I'll take a sentiment analysis model, and then I'll just explain it. Yeah, whether my screen is visible now?
Yes, sir. Yes, sir.
Yes.
Yeah, it's visible, right, Kishore? Yeah, fine. So I'll
Right,
just
sir.
increase that. So the dataset size is little. I'm not going to run this model now. So, but dataset link, drive, the dataset where it's available, everything is given. So as I said that I'm taking one NLP application. So text classification application. This is, I guess, it's a sentiment analysis, right? Sentiment analysis model I have taken here. But it's not that the code will work only for sentiment analysis. If you change any classification data, if you give any classification data, hate speech or fake news, or even an entity identification, anaphora identification, any classification, I'm again repeating classification data set, if you given the same format, the particular code will work. So I'll just to say that I'll go to that. So this is the initial things where you want this NumPy, TensorFlow, and then Pandas. So this, I guess you are aware about the Python other things. I'm not going in deep about that. But even if you don't know about these things, don't worry about that. So knowing this is not at all important. To be frank to me, I'm saying that. So knowing this is not at all going to important now. Just understand what it is. What is pandas, why it is used, what is NumPy, that is enough. So because again I'm repeating, lot of codes are available. Even if you are from the linguistic background, don't feel that as I don't know Python or something. Now we are seeing that doctors are learning programming. Lawyers are started learning Python and started applying for AI models. So, but you use some common sense knowledge and you try to understand what is happening in the code. If you want to modify the code extensively, and then you take some programmer help and then you modify it. But first your step is you take any code and try to understand what is happening. So don't try to build anything from scratch. Particularly, I'm saying that this for that person from the linguistic background. For others, obviously, the coding or the programming is bread and butter for the computer science and IT. So you must learn. Otherwise, we cannot tune the model much. So you cannot, even though you are having a lot of ideas, you cannot implement those ideas in your project or in your research. Fine. So directly, I'm just going to the data part. As I am downloading the data part here, I can say as I shown that I'm downloading the data point here. So I'm downloading the file. I'm extracting the file review.bvz2. So it's an extension compressed file. So I'm converting that CSV file. I'm reading the CSV file. Now, after reading the CSV file, I have something called a data frames. So where I'm telling that I'm giving some instruction here. If you see that I'm converting the data sentiment into one. So say, for example, this is my sentiment label. So earlier my actual data is having something like a positive and the negative, but I don't want to use the word positive negative as a label because it's a categorical thing. I want to convert that into 1-0. That's what this line. So once I converted this, I just printed some data. If you see that this is my text review and I have the sentiment. This is a very simple NLP example. I have a text here and this is a label. So I have a text, this is a label. Fine. So the complete text I'm printing here. So remember that this complete text is a sentence. Sorry, it's a document. It's a complete document. As it's not a single sentence I'm giving, I don't want the review. The complete document I have given here. The data set is complete document, and we are going to find out we are going to make a machine learning model to learn the sentiment out of it. Fine. Before that, I want to see that data count. So what is the size of the data? So I have 25,000 ones and I have 25,000 zeros. It means that 25,000 samples are positive, 25,000 samples are negative. So reviews, I'm having that. So now from the data, this is my data frame, right? The whole CSV file, if you see that, the whole CSV file, I mapped to the data. This is my data frame. From the data frame, I'm going to segregate that reviews and classes. So that I'm going to segregate that. I'm telling that in the data frame, the review column, I'm taking the values of the review column and then I'm storing it into reviews. In the data frame, I'm taking the sentiment sentiment column values and I'm storing it into sentiment. The size of the reviews will be, what will be the size of this reviews and what list? This is a list here. What will be the size of this reviews under the sentiment? Participants? What will be the size of this reviews variable, reviews and sentiments? Am I audible, right? Any idea, participants? Oh, I explained here that, right? The 25,000, 25,000. That is your whole data is 50,000. So you have 50,000 sentences, 50,000 class labels. So I'm segregating that 50,000 into training, validation, testing. So I hope you have the basic machine learning knowledge of what is training, validation, testing. So I'm not going to touch that. So you are converting that. So you are converting, you can see that you are taking training, you are taking small sample I have taken. I just put in a reverse way. Only 5,000 samples for training, 5,000 samples for validation, 40,000 I have taken for testing. purposefully to see that model if I feel if I'm just giving more data for testing. Fine. So I'm using the basic pre-processing steps. For that, I installed some of the libraries. So the basic pre-processing, I may have a lot of HTML tags. So I'm replacing the HTML tags, and I'm just there will be some ASCII or some other characters apart from ASCII characters will be there. So I'm just removing that unwanted characters and noises I'm removing. So with respect to the pre-processing, so as I said that if anything apart after removing also if anything apart from A to Z, capital A to Z or 0 to 9, anything is there, I'm just removing it. Fine. So these are basic pre-processing. So we are doing that. And whatever the reviews after pre-processing, we're getting that, I'm calling it as a normalized training, normalized validation, normalized testing. Now I'm going to run a simple logistic regression model. So I'm just going to explain only one model now, logistic regression Baga-Birds model. So now I have my data, right? Training text is my data. So there is something called count vectorizer. Tomorrow we are going to see the advanced version of the vectorizer. Tomorrow we are again seeing the embedding. The count vectorizer will do the how many words are there in the corpus, how many times this particular word occur in this particular document. That is a count vectorizer. So in my documents, so I'm using the package count vectorizer and then I'm creating the count vectorizer. So now for that count vectorizer CV, I'm transforming that count vectorizer to, I'm applying the count vectorizer to my training text and testing text. Whatever output the count vectorizer has given, I'm calling that as my features. I'm repeating this is called a Baga-Birds feature. It means that the words, unique words will be considered here. So after converting, if I see that the word size will be 21,000 unique words are there in my corpus. So I have a, so one second. Fine. So 21,000 unique words are there in my corpus. I have 5,000 is my sentence count. So I'm having 5,000 cross 21,000. So the features I have listed here. I just printed the size of the feature. This is a quite big one, so I couldn't print the features. But if you want to convert, if you really want to see the sparse matrix, you can convert that into a file. You can store it into a file, and then you can see that you can open file in a Notepad++ or in a Linux system. You can see that file. So I suggest you, even if you convert into a small data set and then you visualize that data features, how the features look like, what are the values, why here the 1, why here the 0, why here the -1. Those things are all try to understand it. Now I'm taking the machine learning classifier logistic regression model I'm taking. So I have given the standard parameter setting. I just given that. Now I'm going to train the model. So my training features I'm giving, and I have this training labels. I have sentiment labels. I'm passing it here. So the whatever the output, so anyway, I'm fitting to the model LR logistic regression model. The model trained and stored the parameters in LR. So from the LR, I'm going to predict. So as I'm going to predicting for the unseen data, I'm passing my test features here. So obviously I'll get my output for my test features. Remember, I given 40,000 data for testing. So my output will be 40,000 ones and zeros. Now we are coming at the end. Now I want to see that what is the accuracy for my model. So I know that what the model is predicted. My logistic regression Baga-Birds model predictions, I have taken that. And the test sentiment, I already know the actual ground truth values of 1 and zeros. So when I compared with the classification report and the confusion matrix, so I got the results like this. So the 85 is a F1 score for the class 0. Again, the class 1 also I got interestingly 85. It means that the complete accuracy is 85%. Remember, I trained this simple model with 5,000 samples. I tested with 40,000 samples. So that's the reason we got 85. If I did in a reverse way, 40,000 for training, 5,000 for testing, definitely I would have get about 95% result. So with this, I'll just stop now. So if you have any questions related to the today's presentation, you can ask. And tomorrow we'll start with word embedding. Yeah, Kishore, participants, any questions you can ask now. Do you have any questions?
So today, do you want to explain about key query values that attention want?
Yeah, so I'll tell that no issues actually. So you ask about query, key, and value, right? So what
Yes.
application you are applying to that? So I'll tell with exactly with your application.
For example, means machine translation from one language to another language.
So you are applying for the machine translation, right?
Yes.
So the machine
Yes.
translation, you are using neural MT.
Yes.
So it means that you are having the parallel corpus. Say for example,
Yes.
you are going to translate from English to Hindi. I'll say that you have a
Mm-hmm.
English sentences and you have a Hindi sentences,
Hmm.
right? So you are
Yes.
going to build a translation system between English to Hindi, right? English to Hindi, from English to Hindi. So your query is the vector, embedding vector of your English sentence, because the model is trained such a way that the attention model is trained such a way that your input is English. So okay, fine, you are going for a machine translation. What you are going to achieve actually after training is over, you are going to give an English sentence, the model is going to give Hindi sentence as output, right?
Yes.
So you just treat that as a kind of information retrieval model, where you are giving query as a English sentence, you are giving a query, the model will give an answer as the Hindi document or Hindi sentence. So that's the reason the query is in your application. Query is English sentence embedding vectors, right?
Okay.
And you have something called key, right? Your key
Yes.
is the equivalent English sentence vectors reference Hindi sentence vector. That is your key,
Okay.
right?
Okay.
Now,
Huh.
what is value? Your
Values.
value will
Target.
your
Yes.
value will be actually, you have, as you are using the parallel corpus, your final output, what do you want is you are going to generate Hindi sentence. Am I right?
Yes.
So the Hindi sentence you are going to generate in your corpus, you are giving, say for example, 50,000 Hindi sentences you are giving in your corpus. That 50,000 sentences, Hindi sentences vectors are called values. So the understanding, the association is, if you are giving an English sentence as a query, you are giving, so the model will understand the similarity between the query and, you know the formula, right? The similarity between the dot product between the query and key, right?
Yes.
The equation of
Yes.
attention. So it's finding the similarity between so the query and then key vector, and it's extracting with the help of value, and it's giving the final Hindi sentence. I hope I answered your question.
Yes, sir. Yes, sir.
If you want detailed one, because this attention itself a big one, there is a uh,
Mathematical expression.
mathematical expressions, and then the paper known as attention is what all
All
you
you
need.
need. Yes. Yes.
So there are good audio, there are good, sorry, YouTube materials are there. You just refer that, and then definitely you'll understand, you'll get idea.
Okay. Okay. Thank you, sir.
Yeah, so in order to detailedly explain that with respect to your application, that's what I haven't answered that time. So otherwise it will be deviated, right?
Okay. Okay, sir.
Okay, yeah, thank you. So any other questions? Yeah, Kishore Babu sir.
Sir.
Yeah, so I think no other questions. Then shall we wind up?
Okay, sir. Okay, sir.
Fine. So the
Thank
tomorrow we'll start 4
you.
o'clock. Tomorrow we have word embedding. We'll see that.
Okay, sir.
Word embedding, and then day after tomorrow, last day, morning 9 o'clock we'll keep 9 o'clock large language models.
Okay.
Okay, fine. So fine. Thank you all.
Thank you, sir, for your wonderful session.
Thank you.
Thanks. Thanks.